application development. So we have seen how to use optimized libraries so that your application also is optimized with respect to the underlying hardware platform. Now we will look at yet another tool that will help you fine-tune the performance for different cores within a processor. So these days, whenever we look at any device, the devices are either dual core, quad core. So what does that really mean? So a core within a processor is an execution unit, and the more number of cores you have within a processor, the processor has the capability to execute multiple tasks simultaneously. But if an application is not really programmed in such a way to utilize or to leverage on this multiple core functionality, the cores are not used efficiently. So there will be CPU cycles that are kind of not used to the best advantage in the application. So there is yet another tool which is Intel Threading Building Blocks, or TBB as we call it, which helps in really utilizing the multiple cores within the CPU in a very, very efficient manner. What is this Intel TBB? This is a C++ based template library, or an STL kind of an interface provided by Intel. How does it help? It helps by utilizing multiple cores, thereby speeding up the execution of different instructions within your application. That is one part of it. It also helps in reducing the power consumption within your application. The more cores that you utilize, the better it is for the power utilization within your application. So you can write performance optimized as well as power optimized applications if you use Intel TBB. This is an open, or rather I would say that there are two versions of Intel TBB that is available. One which is an open source version. There is threadingbuildingblocks.org, under which you can find the open source version of this tool. But there is also a licensed version that you can find under software.intel.com. So this diagram explains the different aspects of, or rather the different functionality that is supported by the threading building block. So if you are doing a lot of computation which can be done in general parallel algorithms or generic parallel algorithms, TBB is the best library to be used in your applications. Similarly, if you have concurrent containers, you can make use of TBB to really fetch data, store back data simultaneously. TBB also provides you with APIs for thread safe timers. It also provides you OS API wrappers for even creating threads. So you can really make use of these and then ensure that different activities which are not really dependent on each other execute in parallel, thereby increasing the efficiency of your application. There are different wrappers provided for mutex operations and also conditional variables. So TBB exports or exposes a library which kind of abstracts all these functionalities within its APIs. I can again go back to Eclipse and show you a sample where TBB is utilized. Again, TBB is a C++ library, so for you to be utilizing TBB, your application has to be an NDK application. So we again go back to the JNI folder, which indicates that this is already an NDK application. And when I open the android.mk file, very similar to what I showed you in the case of IPP, there are multiple defines that are available here, and each one of these indicate that the TBB library is being used. And if you see here, we say that one of the libraries to be included is the libtbb.so. So once we include this, it is an indication to Eclipse that we are going to make use of the TBB library, and you can go ahead and use different functionalities of TBB. So there is also, this sample is also provided along with TBB when you download it. And in the application.make, here you can again see that it has x86 under app_ABI, and app_STL, we will have to this is the general STL library on which TBB is dependent on, because TBB in turn is also a standard template library. So in summary, if we look back, I have spoken about 4 different tools that are available for efficient development, profiling, performance optimization, and fine-tuning of your applications based on the kind of functionality that you are making use of in your application. All these tools, along with certain other tools, are provided to you in a single package by what is called the Beacon Mountain. Beacon Mountain is a tool suite that is available on software.intel.com. It's a comprehensive development environment specifically for native Android apps, but this is not restricted to native Android apps. You can even go ahead and develop Dalvik-based apps with this tool suite. One thing to notice here is this, even though I have spoken a whole lot about Intel x86 and Intel-based hardware platform, this particular tool is available for both Intel as well as ARM platforms. So you can use some of the tools here for ARM as well. So here there is a list of applications that are developed within Intel, so that is what I have covered as of now. There are also a list of applications that are used from third party, or rather we have borrowed from a different vendor. So as you can see, the entire Android ADT bundle is available when you actually install Beacon Mountain. Similarly, the Eclipse IDE is available to you when you install Beacon Mountain. Android Design, which is again a standard tool by Google, is also provided to you as part of Beacon Mountain. So in summary, for making your development process efficient and to enhance the user experience by providing better performance to your applications, you can use the Beacon Mountain tool suite for your development process. So this is what I had as a presentation. These are the contact details, so you can either contact me or Nalina if you have questions about the different tools that we have spoken so far. Now I will open it up for questions. Thank you for your patience listening.